Welcome guys, welcome once again, and we'll be talking about data types and contract structure. Right, so let's just dive into it. Right, we're gonna start with, the first thing is going to be definitely our license identifier, and we are going to be using MIT. While we are using MIT, I basically included some comments at the end of the GitHub gist that I would be adding to this video, so check the description to see all of that. And then we have the pragma solidity 0.8.21. so this caret sign basically means it can run up to 0.9. so we have that there. So we have also the first contract, which is the contract treasury, and this takes primitive types. So we have the address, which is public and owner, and then we have the uint 256, which is public and takes this total deposited variable. So we have uint and int. I want to briefly explain what the difference between uint and int is. So integer can take negative values, so integers can take -9, -10, -100 up onto -2 raised to power 256, while the uint can only take positive values. It can only take values from 0 and above. It cannot take any negative values. So that's a very short introduction about that. I also added some more information about uint and int in the comments that are below this code. So we have constant and immutable examples. So now we are taking a uint 256 public constant variable, and we are pegging that to 10 ether. This is a very gas efficient ways to add things directly to the block, because the blockchain knows we are not making any change to this, so the value is constant, it is fixed. We also have another keyword, which is this immutable keyword. So it's basically taking the start block, and this is set once the constructor function has been called. So when a smart contract is deployed, a couple of things are set in stone and they are imputed into the constructor function. So we have the owner, which is equals to the message.sender, and then the start block, which is equals to the block.number. So we have two events here. One is the deposit and another one is the withdrawal. So the deposit function takes the address which is indexed from, and it takes the amount, and then the withdraw function, or the withdraw event rather, takes the address which is indexed to and also takes the amount. So note that this is a test smart contract, right? But it still works, and we are going to interact with the smart contract also. So we have the payable function. Once we have a payable function, that means that we can add it to the contract balance, right? So this function is a deposit function that allows the smart contract to accept it to it. So we have two error handling tools here that basically can handle errors that comes with adding it to the contract balance. We have the first one that requires the message.value to be greater than 0, or it returns 0 deposits. And then we have another one that requires the message.value to be less than or equal to max underscore transaction, or it says that the max transaction has been exceeded. So we have these two things. We would see them in play when we test the smart contract. So we have an example of an arithmetic operatic example here, where it says the total deposited is plus or equal to the message.value. So this is shorthand for the total deposited is equals to total deposited plus the message value. Very, very short. So this returns the total deposited. Now we have another function as reached cap, which takes the cap a uint 256 value, is external and can be viewed by everybody. It returns a bool value or a boolean. We know that booleans are yes or no. Now if you still do not understand this code, you can simply go to ChatGPT, put this function in and say, what does this function actually mean? What does this function actually do? Right, so we can do that also. Then we have a modifier here. Right, it's very important that you understand how modifiers work. So when we have a modifier, right, a modifier basically acts as an access control. So this modifier is saying if the message.sender is not the owner, we revert not owner. We are going to see this in play in the smart contract, but just note the logic here. If the message.sender or the person interacting with the smart contract is not the owner, we revert back to this. So the error is the not owner address color. So this is a custom error definition. We also have another example or another function here, which is the withdrawal, and it is external, but it can only be triggered or called by the owner of the smart contract. So we have this modifier function here. So only the owner or the deployer of the smart contract can call this function, and it takes a couple of parameters, as we can see here. So now we have something known as a child contract, because this basically extends the treasury and adds other features to the first treasury contract that we had here. So let me try and collapse this so that we can see this other function. Okay, so now we have this contract here, and then we have the other one. So when we say contract treasury plus is treasury, it simply means that it is taking all of the functions, everything associated with the treasury contract that we have at the top. Simply put, this is a child of this. So everything that this parent contract has, this treasury plus has it also. And then we can also add other features to the existing treasury contract. So we have an enum row here, which takes several parameters: none, admin, auditor. And then we have a struct, which takes your row, your uint, and the allowance that you have. Also, I added more explanation on this in this part, the comment section. So you can basically just come here and basically get more explanation on what we are trying to do. It's very explanatory, so you just scroll down here in the GitHub gist, and then you get better explanation on everything. Okay, so we have a function to approve allowance, we have a function to set the allowance, we also have another function here to count admins. So that basically sums up the contract, right? We have the auto compiler on here. It's best practice to always just have this on so that if there is an error in your smart contract, right? So it's green, so we can see that the compilation is successful. Then we can basically move to the deployment. We are not going to be deploying to a testnet. We're just going to be using the development environment that we have on Remix. We're going to be using Remix VM Prague. So I'm going to be using a new account, all right, because I've been deploying this contract, I've been working with it. So we're basically just going to start fresh, right? And we are going to deploy, so we can see that it deploys successfully, right? We can see all of the function here. So this is the treasury plus, and then this is the treasury. So we have two smart contracts here. Right, so let's test trying to put in 20 ETH and let's see what happens. Let's try to put in 20 ETH. Let's see what happens. We get an error. Let's zoom into the error. We see the error here clearly says max transaction exceeded. So this is the reason that was provided by the smart contract that we basically imputed. So if we try to put in 2 ETH, you see that the balance here is updated to 2 ETH. So I basically just want you to play around with the smart contract, with the child and the parent smart contract. Just play around with it. If you have any question about any particular function, you can basically just copy that function, paste it on your favorite artificial intelligence tool, ChatGPT, Gemini, Cursor, anyone, and there's still like a this comment basically still explain everything that this contract has, right? So if you follow the comment, you can still basically follow through and understand everything that we've done. So that's it for today. Up until the next one, do have a lovely day.